Okay, so here's number one. So the depth of water in tank A in inches is modeled by a differentiable and increasing function h for this time interval, where t is measured in minutes. Values of h of t for selected values of t are given in the table above. Now, guys, right away, I want to note two things. Okay, so differentiable is also going to imply continuity. So also continuous. So basically differentiable, continuous and smooth. Okay, and increasing, guys, there's a couple things that this could help you with. If they're telling you that a function is like always increasing or decreasing, or that it's concave up or down, they could later ask you to do some sort of approximation, over or under approximation. Okay, and the two things that would give, or the thing that would give an over approximation for an increasing function would be a right Riemann sum, and then an under approximation for an increasing function, that would be a left Riemann sum, would give an under approximation if the function were increasing. Okay, so use the data in the table to find an approximation for h prime of 6. Show the computations that lead to your answer. Indicate units of measure. Okay, this is 2 points. All right, so h prime of 6. Guys, I'm not going to say equals because this is not equal. This is an approximation. And from this table, first let me find where it is. So if all we got is a table of values, we have to use AROC. So are you just going to use one AROC, or are you going to use two AROCs and average them? Two AROCs and average them would be like if they wanted h prime of 2 or 5 or 7. Where you'd be estimating the derivative at some interior given point. But here we've only got one option because 6 is not in the table, but it is between 5 and 7. So this is going to be h of 7 minus h of 5. Okay, we're using AROC. All right, now the units. So these up here, just pay attention to the units. These are inches, and then down here we're doing minutes. So it's going to be inches per minute. All right, so 18.5 minus 15.5 over 2. And this is 3 over 2 inches per minute. Okay. Alrighty, approximate the value of this using a right Riemann sum with 4 subintervals indicated by the data in the table. Is this approximation greater than or less than the actual area under the curve? Give a reason for your answer. So this is why I mentioned the increasing thing. That's gonna help us in our determination. Okay, so right Riemann sum. So for a right Riemann sum, if you're looking at a table, all right, we got these rectangles that are approximating the area under the curve. So for the first rectangle, this is the base, all right, this length. So that would be base 1. If it's a right Riemann sum, you're using the height from the right endpoint up to the graph. So this would be height 1. So you're never going to use that first y value in this case. All right, so that's base 1, height 1. And then this length here is base 2. That's height 2. This is base 3, height 3. Base 4, height 4. Okay. So, the integral from 0 to 10 h of t dt is approximately, right, the first base has length 2, and times 10. Next base, 3. The next base is 2. The next base is 3. Okay, and this is a calculator section. All right, you add all of those up and you get 163.5. Okay, so guys, we got 2 points for that. Okay, it's 2 points for doing that. Now the explanation. Okay, so they want to know, is this number greater than or less than this? Okay, and you could use words or an inequality if you want, but 163.5 is greater than, okay, because since H is increasing, a right Riemann sum gives an over approximation. Okay, so that would be the third point right there. Okay, so yeah, here we go. So next, the depth, so this is 2 points again. The depth of water in tank B, so another tank in inches, is modeled by this function for this time interval, where t is measured in minutes. Find the average depth, so we need our average eval formula. Find the average depth of water in tank B over that time interval. Is this value greater than or less than the average depth of the water in tank A over that time interval? And give a reason for your answer. Okay, so, yeah, all right, so I'll use notation. Oh, and by the way, guys, I should graph this. Or if you're in a calculator section, you should graph the stuff they give you, like any functions. Okay. And then the time interval is 0 to 10. All right. Okay, so that's in there for later. I don't need to look at the graph now, but we can. All right, I didn't change my y min or max. Okay, I don't really see much happening. I can go back to the window. Maybe I just need to be much higher, like up to 50. Okay. All right, so that's what that looks like. That is the depth of water in tank B. And now that's stored as Y1. So if I need to use Math 8 or Math 9, I could use Y1. Okay, anyway, so average value. So that's like this bar notation. Okay, so G bar of T, that'd be the average value of G, and this always has to be over an interval. So I'll put like the interval down below. This is equal to 1 over the length of the interval times the integral okay, just like that. All right, now guys, I can use Math 9 for this. So calculator section, so make sure you're in radians for the whole test. Let me go to the home screen. 1 divided by 10, Math 9, 0 to 10, alpha trace, that's Y1. Okay, 16, now you need 3 decimal places. 16.624, and this is inches. Okay. Did they ask for units? I don't know. All right, so there's that. Now I gotta decide if this is greater than or less than the average depth of water in tank A. So for tank A, all we have is this table. However, the average value or the average depth in tank A would just be the average value of H, okay? And so that would be 1 over 10. You know, we would just use the same formula, and we'd have 1 over 10 in front of this integral. So we could take this and get the average value of h, okay? So h bar of t over the same interval. Now, this is not exact, okay? So this is approximately 1/10. Oh, no. I won't say approximately yet. Sorry. Is equal to 1/10 the integral from 0 to 10 h of t dt. Okay, now this is approximately just the answer from B divided by 10, 16.35. Okay. Now, okay, so this number is definitely greater than this number, okay? But remember, this number is an approximation. So does it mean that, so does it necessarily mean that this number is greater than the actual average value? Well, guys, because we already established that the integral is giving us an over approximation, if this is already an over approximation and it's less than this, then of course the actual average value of h would have to be less than. Okay, so yeah, you just want to explain that somehow. So greater than, so the answer is greater than the average depth of water in tank A. Greater than because since 163.5 is an over, or I'll say it like this, because 165 or 163.5 is greater than this, the average value, or I'll say, sorry guys, I should have thought this through, 16.35 is greater than the average depth in tank A, which is less than the average depth in tank B. Okay, guys, I hope you don't have to use my exact words, but that's the logic there. Okay. And you could have explained it more concisely using notation, like inequality notation. Okay, but there's that. That's 2 points. All right, according to the model given in part C, is the depth of water in tank B increasing or decreasing at time t equals 6? Give a reason for your answer. So guys, you always want to be thinking, okay, depth of water in tank B, that's G. So you always want to be thinking of Susan's table. G prime, G double prime. Okay, this is the depth of water in tank B. This would be increasing if G prime were positive and decreasing if G prime were negative. So, guys, this is a calculator section. We need to find G prime of 6 and see if it's positive or negative, and you could use Math 8. Okay, so Math 8, oh, you can't see. Okay, now I'm going to write that down. 0.887, okay? And this is positive, Okay, so the answer is increasing because g prime of 6 is greater than 0. Okay, and that would be 2 points there.